Last time we talked about string types. So we have string reference, string slice, and string type. And today we're going to talk about other types from the standard library, which are the, so we have three, I think, option T. And we want to talk also about, well, vecti we talked about already, and then result, the. So as you can see, these guys, these three types, they take a parameter. They take a parameter type. So they themselves are not technically types, because if you take a vector by itself, you don't know a vector of what it is. And therefore, vector itself is not a type. Sometimes it's called a high order type, because it's a type, it's something that creates a type if you give the parameter. In kind of the same way that this is not a value. Well, but it's if you have a function f that returns something, the function itself is not a value. The value is f of 1 of 0, for example. But the function creates a value. So here we have higher order types, because by giving a type, you create a type. Sometimes they are called type constructors, or generic types, or parameterized types. So you can see there are many names for this. So not super complex if you think about it, right? It's just the fact that if we have a vector, all the implementations will be the same, except that the container type, the stuff that the vector contains, is going to be different if you have a vector of integers, or a vector of strings, or a vector of floats. But the functions themselves that apply on the vector, which is accessing a vector by key, by index, is semantically the same. We also saw before hash map, and we also saw set. And these guys are, we didn't see hash actually. We see hash later. Hashes are very important. So we saw set only for. All right, so let's see the first one, option T. Option T is, so another thing is all these types, these three types here, what they do is they add some functionality, some behavior, so some semantic on top of the type that they're wrapping. So, for example, if you talk about a vector of T, what they do is they add the idea that instead of having one instance of a type, we can have 0 or many, and then we can compose that. So we can make a vector of vector, a vector of option of vector, and so on and so forth. Since the result of applying option on the type is a type, I can continue by using the result option, for example, option of U8 as the inner type of another option. So we see whether it makes sense or not is another question altogether. But at least we are allowed to do that from the semantic point of view. And the compiler will not generate an error if we do option option. And we can go on, we can do option of vector, and so on and so forth. So any combination is at least syntactically correct. But what about semantics? What's option? What's the meaning of option? So we saw that the meaning of a vect is 0 or many instances of T. For option, it's even simpler. It's either 0 or 1 instances of T. And in other languages, this concept of having an optional instance. So, for example, if you pass a value to a function, but sometimes you don't want to pass a value, the value is not required, or you want to indicate that there's no value, or the function returns a value, but sometimes it doesn't return anything. It's a very common requirement to have. This is a very common need, right? So, and in the first languages like C or Java, they used to represent that with a special bit pattern, value pattern, which was the null. Null is something that very common in all of the first languages. Actually, many languages still like that. But unfortunately, we came to, I mean, language designers after a while came to realize that many bugs are caused by the lack of differentiation between a function that must take a value, that you must pass in a value. So, for example, you have a function f that takes a u8 or returns a u8. Sometimes I need to give to tell that I don't return a u8. So example, it would be getchar. So take getchar from the standard library, C standard library. It is a function that essentially takes an input from the keyboard, from the terminal or standard input. So there's a version with a file. So fgetchar would take a file as a parameter. But let's stick to getchar. Most of the time, you will get a character, right? This character would be something that you press. We have A and it's translated as an ASCII code. So A would be 65, space would be 32, and so forth. So there's a translation table called the ASCII ASCII table. But also, you also want to convey the fact that there will be no more value. So, for example, the terminal is closed. Close the file, and there will be no more data coming. In which case, you want to return either as an error, or you want to return as something called end of file, indicator that is the end of file. So if you do that with if the signature of getchar was U8, was only 1 byte, it would be impossible to convey this information because any value from in a byte from 0 to 255 is technically possible to generate with a keyboard sequence. So we need a value for a return value that is outside of the range to differentiate a real result from end of terminal, end of file. The way that C does it is by actually not returning a U8, but returning an int, which is most of the time either U16 or U32, at least greater than U8. So the real signature of getchar is this one, or something similar to this one. But you can see that it's not very clear because from the signature itself, there's no indication that that's what the meaning of it's not even U32 is I32 because the return value that is which is an error or end of file is -1. If I did a U32 and I return -1, it will be out of range. It's negative, and so it's I32. But seeing the signature like that, I don't really know that was the intent of getchar. I can't tell that it's I32 because the signature is for the passing -1, or it's because it's to get it compatible with other functions. Sometimes that's the reason for some return times to be larger than they should be. And then there's also the chance that even if I handle the return value properly in getchar, the caller of getchar does returns the value as R32 and then propagates another function and which does not know about this. So what I'm trying to say is that this kind of signature is very error prone because -1 as error condition or a boundary condition, I should say, because end of file is not technically an error, but it's definitely not a usual case. Let's call it a boundary condition. Returning -1 is not something that is standard and is not going to be checked naturally by other functions. So what option offers to you is wrapping default type, standard type, or wrapping anything basically that you want to return normally. So in this case, it would be a char, so U8, and adding the fact that I can also tell the return value to be none of the type inside, right? Because option is it's actually an enum, it's a union type that has two values. So pseudo definition option is something like that, where I have two possible values. One value indicates that there's nothing inside, so that would be the case if the file is closed. And the normal case where I actually do have a value, in this case it would be sum of t. Right? So it's a generic type, therefore I'm allowed to use t here. So syntax here is actually not good. It should be like this one. So you can read this as either it's an enum type, so it's a union type known that has no type parameter, or sum, which is a struct that has one anonymous field. So you can see this is actually a valid definition. So if I call it option 2, my option 2 is okay. The zigzag here is simply because my function does not return anything. So technically it's an error. But let's put it to do. And because the type is correct, the compiler is okay with that. So now, if you look at the definition of this function, it's clear from to anybody that there's a possibility that this is going to return no value. It's going to return no. And if it returns some, then I need to I have to handle both cases. That's the point here. So let's see how we use it. Let's say that somehow, somewhere, we call this function getChar. And now, so I don't need my custom-made option. I will just use a standard option. So you can see the compiler has determined that the return type is option U8. And as an option U8, it's not necessarily a value. So if I try to print A, I will get a compiler error because the A itself, the option, is not printable. It's debug printable. I can do that, and then it will print out something unknown. Right. So for example, if I do this and I run it as a debug print, I can see it's known. And if I return a value, so let's say I return 5, then it will also print sum 5. But if I want to access the value inside, then I have to go for an extra step. I can either decide to take the value, so I can unwrap it. And now if I unwrap it, I get a type inside. So it's like an option was a box or package, and the type is inside, the instance is inside. So if I unwrap the option, I get the inner value. If I print this, so you can see that I'm going to get 5. But what happens if I unwrap something that does not contain a value? If I unwrap known, then I get a runtime error. It's a panic. The program panicked because by using unwrap, I'm telling the compiler that I know it should not happen, and if it happens, it is a problem in my code. This is something that it was not supposed to be happening. Therefore, I didn't handle it gracefully. So you can see the error is much more blatant, much more obvious. It's not something that if I had -1 and I pass it to a function, there's a chance that -1 will go undetected for a while until it gets to another function that maybe prints it out, or maybe there's some calculation based on the keystroke. And therefore, -1 will be then interpreted as a completely different value than normal. But here, as soon as I unwrap it, I get a runtime panic, which in most of the cases will simply terminate my program. And failing fast is better than having a silent failure way later. So I would much rather have this failure right now because I can go and fix my code rather than leave it to production and potentially have a very sneaky bug that will emerge years later. So this is one of the reasons why people like this option type and the Rust strict typing system. But let's see. What if I actually can have, so getChar normally is allowed to return known. What if I want to handle it better? So I have actually a couple of options. Right? I can say that, but I have to handle both cases, right? I cannot just like pretend that known does not have happened. So I can do a match, which is a pattern match. So match is like a switch in C, a powerful switch in C. I can give where I can give a pattern. So I can give the pattern some x, ax explorer, and do something on that. And if I just leave it like that, the compiler will tell me that there's error because my match is not exhaustive. I don't handle all the cases that are possible. So that's also helpful because, contrary to C, C does not enforce this, and you may have a sudden bug where A is known, and you would fall through. So let's see that if it's known, what can I want to do something else. So in the first case, I will print the value AX, which now is U8. So the pattern matching stuff, pattern logic is I give basically an example of what value, how the value would be. So something, and the compiler will generate code that extracts the variables based on the pattern on the template that I'm providing. So in this case, since AX is a U8 in an option, then I can print it like that. And if it's known, I'm not going to do anything for the moment. So if I run this, I'm going to get nothing, no crash. I'm just entering this code here. Let's make it apparent, obvious by actually printing something. So let's print no value. There run this. So this is a case where I have no value. If I have something inside, then I should follow it through here. Right now I have something here. So, but if I don't have this branch, so actually in some cases, I don't need to do anything when it's known, right? Now the compiler will say, but back to the case before, right? Something is missing, so I'll put known, and I put the empty statement. You can see though that the starting, this is not an error, but there's some gray highlighting, which tells me that from starting point of view, it would be better to use if let. So this case is so common that the language has a shortcut for it. You can do if let and then put the pattern here, right here, and match it with the value, the variable. So this syntax here is strictly equivalent to the match that I wrote with earlier. So this is exactly the same. If this guy doesn't match, if A doesn't match the pattern, if I cannot do the let, basically, if the let doesn't make sense because A would be known, or A is not a sum, something, a sum and then something inside, then this condition is not true, and we won't go inside the code. You can see though that it's a shortcut code, and it's much more idiomatic to do so. Print this and codify. So these are two of the ways. As an option, also there are cases where I get an option, right? So I get an option of U8 because I call a character, but I want to operate on the value that is inside the option only when there's a value inside. And if there's no value inside, then just leave it like unknown. So what I'm trying to say is that I want to do something that semantically would be b equal a plus 1, right? But I cannot do that because a is not a value. It's not a U8. If you have a plus 1, the compiler will tell me I do not know how to do a plus on an option. An option is not arithmetic type. So I can't do that. But what I meant to do is to do a plus 1 on the value inside. So option has a method of associated function, if you prefer, that takes a function as a parameter. So in this case, the function would be x plus 1. So, and then this makes an option. So you can see that the type here, option U8, hasn't changed, but it could change. It depends on the type of this function here. So if, for example, I did A as U32, so I'm taking U as U8, but I'm making it bigger. I'm widening it. So now I can see that B is option of U32. This syntax here is called a closure or a lambda function. It's, for the moment, let's just consider this as a shorthand for actually writing a function outside. So I could write a function outside that is it's just like that. U32 and x as U32. This is the same as this one, but I declared it as a full-fledged function. In which case I can pass it f as this. There are some subtle differences between this and this, but we'll see in another topic later. This is a function, and this is really a closure, not exactly the same. But for the purpose of option, and I will talk about option, this doesn't matter. Okay, so you can see that by using map, I can apply a function inside the inner type, on the inner type, and leave it known untouched. So if I do this, right, if I do this stuff, and then now I print A, so let me print it with the debug so that we can print both known and non-known. So what do we expect? We'd expect, actually, let's do something. This doesn't change the value, so it's not really useful. Let's change that to, say, it increments x. So I have some with a 5. What I want is, expect at least is a 6, because 5 should be incremented. If I run this, I get 6. But now if I do known, and I run it, I keep having known. So this idea that you can apply a function on the inner value is something that we're gonna see it in one way or another with the other types. So if we do that on the vector, what we expect is that the function will be applied to every value of the vector. That's indeed the case, but the operator is a bit different because of some Rust idiosyncrasies. Vec does not have map directly on it. It has map through iterators. So I'm not going to show you like this because it's a bit confusing, not as clean as the case with option. The next one is that we want to do we could do with option. It's very simple. Actually, I have to start with that. It's the idea that whenever you have a value, so if I have a value 5 here, then obviously there's a way to wrap that value into an option. So I can do option and then well, just option of sum of, let's see. Right? So this basically creates an option based on a value. And yeah, that's so trivial that it's probably more confusing than why it's special. Then there's a third one. This is less trivial. It's the idea that if we chain a function that returns an option, so this is one of them. So this is a function that returns option on U8. If I have another one, let's see, how do I call this? I don't know, increment, right? Increment. So it takes a U8, and then it returns option on U8. So this function, if A is less than 10, I will return A plus 1. Pretty arbitrary, but why not, right? Otherwise, I return none. So that's a function that basically, imagine that 10 is the absolute max value. So I'm allowed to go, if it's 9, I'm allowed to go to 10, But if I reach 10, I want to say, okay, this is enough. It should not happen. It's an error. So I return no. Maybe that's because getChar you wanted to have limited to you expect the input to be in a particular range of the keyboard. Not super important the reason, but this kind of function happens quite a lot because this option here indicates success, I have a value, or failure, get me known. We'll see that we have actually a better way to express this with result. But if you don't want to give the reason why it failed, option is particularly fine. Okay, so if we have this, there are cases what you want to do is kind of chain get char and then follow it with increment. So I want to do something. Of course, the notation is weird, right? But then first call get char, and then if it's a success, call increment, and then if it's a success, call increment again, right? And if there is any failure along the way, if for example get char return known, then I expect all this stuff to return known, right? So the way to do that is to say that get char no sorry option. So let's start with option with get char. So now I have option of view 8. I have this method called and then, which takes a function. Again, it's the same as map, right? But the function it detects, instead of being a function that goes from, let's put this guy lower, we same group. Instead of being a function that goes from U8 to U8, now it's U8 to option. So if I just was doing map with increment, which is the idea here, right? Then you will see that the return type is not going to be option of U8, but it's option of option, because the return value of inc is not a flat U8, it's an option of U8. So I have another level of nesting over the option here that I actually technically don't want. I just want an option so that I can keep on going in. Because if I have that, then you can see that if I do b.map increment again, well, now I'm going to have, well, it's not working because inc takes a U8. It doesn't take an option of U8. Right? So there's something going wrong here. So to unpack basically one level of option, I should not use map. I should use and then. And then. If you're familiar with futures, the idea is going to be the same in futures. If you're not very familiar with futures, don't worry. We're going to talk about futures later. So now you can see here that because we use and then, we have the same level of wrapping than A. We have option of U8 and B is also option of U8. So now I can also call and then on B, right? And I basically did this when I want, as I wanted. And the idea of the and then, which is well, so and then similar to map. So what's the logic? The logic is rather simple. It applies the function exactly as map would do. It applies a function, but then it unpacks it by one level. So if the result of this function inc that inside was known, then it's going to be known. And if the result is sum, then the result will be sum, right? So another way to write this is instead of writing it like that, right? Is to say that I have A as a optional U8, but I'm gonna match some AA. So if there's a value, then I'm not gonna call increment. Let's A so increment A. So increment AA, and IA is going to be the return of, in this case. So it's going to be IA. If it's known, then yeah, it's known. Okay. All right, what's the problem here? Battery. All right, so what we have for this case is that option of AA, right? So this code here, or the three column, is exactly the same as this code here. So the idea that you have three basic basic properties on option. The first one being that if you have a value, you can inject that value into an option. Like it's very trivial actually to do so. Just put it inside a sum. Second idea is that if you have an option of you can apply a function that returns another value and use that on the option. So this is the idea of map. And finally, the third one, which is a bit more complex, but the idea that you can chain options together by even if you have a function that returns an option. Right? So basically, if you have a function that returns a regular value, then you use map. If you have a function that returns an option, you use and-then. So these three properties makes that something that sometimes is called a monad. So if you heard the term monad, that's essentially what it is. Okay, so that being said, we have now covered option and vect. Let's talk about result. Result, you can see it's a bit different because it has two types. And actually for generic types, it's, well, you can see right now that you can have practically any number of types. Of course, you have like hundreds of them. I think the compiler, I don't know if there's a limit, practical limit on the compiler point of view, but you can have at least 10 of them. I think that I've seen types are pretty large. So definitely it's not one. Right? You can have 2, 3, 4. It's fine. And the first type is again the standard type that you're wrapping, and the second one is error type. Right? So this is so the idea here is that if a function returns a value, but sometimes returns error, I may want to distinguish the error itself. In the case of option, I could say that the function returns a problem or error when it returns known, but I wouldn't really know what error it was. Right? It could be error that the stream is closed. It could be an error because the key value, the keyboard value that I expect is out of range. Somebody who's supposed to type a digit, but he typed a letter, for example. That's something I want to capture as an error. So result here has similar signature. So let me remove this stuff and go back to the stuff we had before. Result has very similar semantic as option, but so it's a union type as well. But now instead of having just the value when it's a success, so before it would be like some t, if you remember, and then we had known. What we want now is with the name differently, so it's going to be okay when it's return the value, and it's going to be error when it's the other guy. It's error that way. So there are other. It's basically what the result is. Right? So if I have this guy, right, and then I return this guy, so I could return. So main has to return nothing. Nothing is this guy, this type. Right? So it's a special type. Like the way it's U8 is a special type. This guy is a type that actually has nothing. There's no value. It's empty. It's void in C or void in Java. This is this guy, and then I want to return an error. Right. So error also can be practically anything. So let me put like a string as an error. Right. Okay. So now the syntax error remove this and use a standard one, is again simply that a function should return, it's missing the actual result. So I can say that I'm returning OK, it will be a success if I reach the end. And I still have to pass the value, and the only value that is acceptable for the unit type, which is unit type is like void, is this value, unit value. And you can see this is the same syntax as this braces, because main is also a function that takes no parameter. So this is also absence of parameters. So we have that. And if the function was returning an error, what I could do is return error instead of OK, an error of some value. So for example, no good. So this is not a string. In the discussion earlier, we know that this is not a string. It's a string slice, literal string slice. So I need to cast this to a string, to string. And now this is OK. Right, so let me run this. And it says error no good. Right. And if I say, if instead I had OK, I would say OK like that. Right. So by default, this guy here, will you notice that when there's an error, the program will print the error, but if it's OK, it doesn't print anything. Actually, I think I don't think it prints anything. Let's try. Yeah, main has to be void. So main has to be void. So I cannot do this. And if I get void, so it's either main is special. Either it turns this guy, so the main type has to be void. This guy can be anything, or it can be like really void, so nothing. In which case, what you want is something like that. So obviously, this program will not do anything. This one will be okay. Like, so the difference is basically that the main without any return value has no error handling. This one has error handling because if I have an error and this error is the value that I returned from that function main, then the program would print it. It would print error, right? No good. And this error message is not something I've done myself. It's done by the standard library. So in the next video, let's stop here because it's already quite long. But result is very important. So this is the basic way for Rust programs to do error handling, and error handling is a very important topic. So let's make the next video.